My name's Jeff D, and I'm Math Dad. I'm here to help you help your kids understand math. Misconceptions. When students develop misconceptions, learning math can become very difficult. When students have a misconception, they've made a connection in their brain about how something should work, based upon how something else works. What makes misconceptions difficult is that it creates a situation where a student has to unlearn something. And once they've developed a habit of a way of thinking, it's very difficult to unlearn. One such misconception happens when students are learning to add or subtract expressions in algebra. If I have 5a plus 2b, one of the biggest misconceptions that students make is they see it's addition, I see two numbers, 5 plus 2 is 7, but I have this a and I have this b, so it must be ab. 5a plus 2b is not 7ab. We talking about algebra here? Because my kids are in elementary school. The connection to fix this misconception occurs all the way back when we first start to learn how to add and subtract. One of the things that they learn is how to count up ones or count up tens. They may see something like this. 5 ones plus 2 more ones is 7 ones. In other words, if I have 5 objects and I get 2 more of the exact same object, I now have 7 of those objects. Ones is just a label. If our students don't understand that the 1 is a label of what I'm counting, a misconception can start to develop very, very early. What if I have 5 tens plus 2 ones? Is this 7 of anything? Well, I have 5 and I get 2 more, so isn't it 7? What do you have 5 of? You have 5 tens. You don't have 5 ones, or you have 2 ones. You don't have 2 tens. The object that I'm counting in here are 2 completely different objects. One is a 10, the other is a 1. Therefore, I don't have 7 of anything. How do we fix this problem? What we have to make sure that we're doing is we are counting the same object. Instead of 5 tens, I have to think of it as 50 ones plus 2 ones, which then gives me 52 ones. Because I was able to change the 10 to ones, I was able to make these the same object in order to combine. That's interesting, but what if I wanted to count tens? I could have also taken the 2 ones and changed those into 10. It's 5 tens plus 2 tenths tens. In other words, I have 2 of the 10, which gives me 5 and 2 tenths tens. These two represent the same amount, but they have different labels representing what it was I was actually putting together. Here I was putting together ones, and here I was putting together tens. This idea of putting the same thing together happens over and over and over and over again all throughout math as we're learning it. One of the next places that it occurs is when we're looking at measurement units. For example, if I had 5 inches and I added 2 feet, do I have 7 of anything? Well, 5 plus 2 is 7, but I'm counting inches and I'm counting feet. They're 2 completely different sized objects. We have to make our feet into inches, or we have to make our inches into feet. We have to have the exact same object in order to count, or in order to put them together. So I could have 5 inches, and 2 feet is 24 inches. So in this case, I would have 29 inches. I'm not able to add them together unless I understand how to make them the same object. And what's the key to that? I have to find the relationship between the two objects. In this case, 1 foot is 12 inches. There's a relationship there. Anytime there is a relationship between the two objects that we are trying to add together, I can make some adjustments so that I can represent them as the same object. Are there any other examples? There's a concept that we all start to learn when we're in 3rd, 4th, and 5th grade, where this understanding of having to have the same size object matters. It's when we're talking about fractions. I hate fractions. If we have started to make the connection that we have to have the same size object since the beginning of us learning how to add and subtract, when we get to fractions, we can approach it the exact same way. We need a relationship, and as long as we have a relationship, we can make them the same size piece. What if I have 5 halves plus 2 fourths? I wrote it this way on purpose because when I use words, it's easier to see that I'm talking about a label, an object. It's not just a symbol that I'm trying to memorize rules about. You see, there's a relationship between a half and a fourth. It takes 2 fourths to make up 1 half. And if I know that, then I can say, well, this is just 10 fourths plus 2 fourths, which gives me 12 fourths. I could also think of it as 5 halves plus 1 half, and that will give me 6 halves. Once I start to make sense out of this with words, then I can introduce the symbols and students can have a better understanding of fractions. I can see now that 5 halves plus 2 fourths is the same as 10 fourths plus 2 fourths, which is now 12 fourths. Or 5 halves plus 1 half, which gives me 6 halves. I was able to do this because there was a relationship between fourths and halves. No relationship, I can't have the same object, therefore I cannot add and I cannot subtract. So what does this have to do with algebra again? Why is it that I don't have 7 of anything? I have 5 of these objects which I am referring to as A. And I have 2 of these objects that I'm referring to as B. But I don't know the relationship between A and B. Therefore, there's nothing I can do to make them the same. There's nothing I can do to add them together. Think about it like this. If I had 5 apples and then I got 2 bananas, do I suddenly have 7 banapples? Nothing I do can make me have 7 of the same object. There is no relationship that can get me to change an apple into a banana or a banana into an apple. I can't do anything. But if I had 5 nickels and 2 dimes, I know that 1 dime is equal to 2 nickels. So I can then say it's 5 nickels plus 4 more nickels for a total of 9 nickels. Or I can say I have 2.5 dimes plus 2 more dimes, which would give me 4.5 dimes. And if you know anything about nickels and dimes, this is 45 cents and this is also 45 cents, showing that as long as there's a relationship, I can add these things together. That is how we make connections between what we learn in elementary school and what we learn in high school. The big picture of mathematics is amazing. There does not have to be a separate set of rules for each new concept that you learn. My name's Jeff Dean, and I'm Math Dean.
Thank you, Team White Book, for the donation of this awesome White Book board.